Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a truncated cylinder which has been cut by three cutting planes over here. Now let us proceed with the construction of the orthographic projections of this cylinder over here. So as we are going to look at the cylinder from the top, so we are going to obtain the circular projections of the cylinder onto the horizontal plane. So we know that the diameter of the cylinder happens to be 50 millimeter. So we have drawn circular projections onto the horizontal plane. Now we have divided the circle into 12 equal parts such that the sector angle of each one of these sectors will be equal to 30 degree over here. So the 12 points of the top face of the cylinder we have marked on the outside portion of the circular projection, while the 12 points corresponding to the base, they have been marked with red color on the inner side of the circular projection which we have obtained onto the horizontal plane. And the access points O and O1 corresponding to the cylinder we have marked over here. O happens to be the access point corresponding to the top face of the cylinder, while O1 happens to be the access point at the base of this particular cylinder over here. Now having obtained the 12 points corresponding to the top face, 12 points corresponding to the base of the cylinder, and the access points over here into the top view projections, now we know that the height of the cylinder, it is equal to 90 millimeter. So now we can obtain the front view projections corresponding to the cylinder over here. Now we can see the 12 points corresponding to the top face, they have been marked at a height of 90 millimeter from the XY reference line, while the 12 points corresponding to the base, they have been marked in the front view projections onto the XY reference line over here. And the access points O dash corresponding to the top face and O1 dash corresponding to the base of the cylinder, they have been appropriately marked in the front view projections over here. So now we know that this cylinder has been cut by three cutting planes over here. So on the left side, so this is an auxiliary inclined plane which is going to cut the cylinder originating from the center of the cylinder, inclined at an angle of 30 degree with respect to the horizontal plane onto the left hand side of this particular cylinder over here. So the edge view of this AIP, that is the first auxiliary inclined plane, has been represented by black color projections over here. Similarly, the second cutting plane, it is again originating from the center of the cylinder, moving towards the right side of the cylinder over here. And this AIP happens to be inclined at an angle of 45 degree with respect to the horizontal plane. So we have drawn the edge view corresponding to the second cutting plane with blue color line just to distinguish between the projections of first cutting plane and the second cutting plane over here. Now we know that the top of the cylinder, it has not been cut by any of the cutting planes over here. So we can join these two vertical edges and this horizontal edge over here. Now we know that there is a third circular cutting plane which is going to lie at the center of symmetry corresponding to this cylinder over here. So at 45 millimeter from the bottom, we have marked this point. This is the center point of the cylinder. Now from this point, we are going to draw the radius of 12.5 millimeter or the diameter of 25 millimeter over here, so that this circular projection corresponding to the third cutting plane, it can be obtained into the front view projections over here. Now we have divided this circular cutting plane into 12 equal parts so that each of the sector included angle over here, it will also be equal to 30 degree. So now the 12 points corresponding to the 12 sectors over here, they have been identified as A1 dash, B1 dash, C1 dash, D1 dash up to the points L1 dash over here into the front view projections over here. So now we have been able to locate the three cutting planes into the front view projections over here. So let us proceed with the development of the lateral surface of the untruncated cylinder without any cutting over there. So in order to obtain the lateral surface of untruncated cylinder, we are going to use the method of parallel line development method. So from the two extreme ends of the cylinder, that is from the base of the cylinder and from the top face of the cylinder, we have drawn two projector lines over here, and onto these two projector lines, which are horizontal projector lines, now we are going to mark distances corresponding to these 12 sectors of the circumference of this particular cylinder over here. So the distance between two consecutive points over here we are going to mark, and 12 segments we are going to obtain over here. So we are going to open the cylinder from the point 1. So from point 1, now we are going to mark different points as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 1. So that 12 segments corresponding to the 12 sectors of the circumference of the cylinder we have been able to open up or obtain onto this lateral surface development view over here. So we can see there are 12 vertical generators, 1, 1, 1, 2, 2, 2 up to the points 12, 12, 1 and 1, 1, 1 over here. So these 12 vertical generators which we had obtained into the front view projections, they have been appropriately marked into the lateral surface of the untruncated cylinder over here. Now we can see that this cylinder has been cut by three cutting planes. This cutting plane 1, it is going to intersect with 5 generators of this particular cylinder which is standing upright. Similarly, the right side cutting plane, it is also going to intersect with these 5 vertical generators over here besides the central generator over here. So this point will be common between AIP 1 and AIP 2 over here. So now let us obtain the different points of intersection of the cutting plane number 1 and the vertical generators of this right cylinder over here. Now we observe over here that the cutting plane number 1, it has intersected with the 7 vertical generators over here. So this vertical generator is common and 5 vertical generators, they are lying onto this side. So now since we have to mark 7 points of intersection over here, so that is why now we have taken out the angle of inclination of these two auxiliary inclined planes over here. So this angle 30 degree we have taken out. This angle of inclination of the second AIP 45 degree we have taken out, because total of 12 points of intersection we are required to mark it out over here. So now we will observe that the vertical generator 1 dash 1 1 dash has been intersected by the cutting plane number 1, that is black AIP, at the point A dash over here. So now let us locate this point A dash into the developed surface orientation area over here. So we can see point A dash lies onto the vertical generator 1 dash 1 1 dash. So now once we draw a horizontal generator through the point A dash, and wherever this horizontal generator intersects with the vertical generators 1 1 1 on the left hand side and 1 1 1 on the right hand side. So we are going to obtain the point of intersection A into the developed surface view over here. Now another set of points of intersection of the cutting plane number 1 with the vertical generators 2 dash 2 1 dash and 12 dash 12 1 dash, they have been obtained as B dash and L dash over here. So once we draw horizontal projector through the points B dash and L dash, Now let us evaluate the intersection of this horizontal generator with the vertical generators 2, 2, 1, it is this point, and 12, 12, 1 over here. So 12, 12, 1 vertical generator will be intersected by the horizontal projector line emerging from the point L dash. At this point, so we obtain the point L over here. Onto vertical generator 12, 12, 1. We obtain the point of intersection of this horizontal generator emerging from B dash with vertical generator 2, 2, 1 over here. So point B has also been appropriately located into the lateral surface development view over here. Now this is the third point of intersection. Now here we can see that the cutting plane, it is going to intersect with the vertical generators 3 dash, 3, 1 dash at the point C dash, and this AIP number 1, it is going to intersect with the vertical generator 11 dash, 11, 1 dash at the point K dash over here. So 2 points of intersection here we have been able to obtain. Now once we draw horizontal projector through the point C dash, and let us find out the intersection of this horizontal projection line with vertical generator 3, 3, 1. So point C will be located over here, and wherever this horizontal projector is going to intersect with vertical generator 11, 11, 1 over here. So point K will be located over here into the development surface view over here. Now the last 2 points corresponding to the cutting plane number 1, that is the black cutting plane, it lies onto the base of this particular cylinder over here at the midpoint. So now here we observe that the cutting plane number 1, it has intersected with the vertical generator 4 dash, 4, 1 dash at the point D dash over here, and the vertical generator 10 dash, 10, 1 dash has been intersected by the cutting plane number 1 at the point J dash over here. So now 2 points of intersection corresponding to the center at the base, they have been located, D dash and J dash. So now once we draw horizontal projector lines through these 2 points D dash and J dash, let us evaluate their points of intersection with the vertical generators 4, 4, 1 and 10, 10, 1 over here. So onto 4, 4, 1, point D will be located. Onto 10, 10, 1, the point of intersection J will be appropriately located over here. So corresponding to the first AIP, now these are 7 points which have been located over here. And out of these 7 points, D and J points, they will be common with the second auxiliary inclined plane or the cutting plane over here. Now corresponding to the second cutting plane, so as we have discussed, D dash and J dash points, they will be common. So this point D and J, they will also be common with the second cutting plane over here. So the first 2 points corresponding to the second cutting plane, they have already been evaluated as D and J points over here. Now we observe that the second cutting plane, this one, now this is marked with blue color. So now the projection lines also we are going to draw with blue color over here. Now the second cutting plane, it has intersected with the vertical generators 5 dash, 5, 1 dash and 9 dash, 9, 1 dash at the points E dash and I dash over here. So now these 2 points of intersection E dash and I dash we have already obtained. Now using a blue color, that is corresponding to the second auxiliary inclined plane. So using this blue color projection line, now a horizontal projection line we have drawn over here. So let us evaluate the intersection of this blue color horizontal line with the vertical projector generator 5, 5, 1 and 9, 9, 1 over here. So wherever this horizontal projector line emerging from E dash and I dash, it is going to intersect with 5, 5, 1. Point E will be located wherever this horizontal projection line, it is going to intersect with the vertical generator 991 point I has been appropriately located. Now the next 2 points of intersection of the second cutting plane with the vertical generator 6-61- and 8-81-, they happen to be F- and H-. We can check points F- and H-, they lie over here. So from these 2 points of intersection, once again we have drawn a horizontal projector line, and wherever this horizontal projector line, it is going to intersect with vertical generator 661 point F will be located. Wherever this horizontal projection line, it is going to intersect with the vertical generator 881 point H will be appropriately located over here. And finally, the 12th point, that is the G dash point. It is the point of intersection of the second cutting plane with the vertical edge 7-71- over here. So through this point G dash, which is lying onto the vertical generator 7-71-, now if we draw a horizontal projection line, wherever this horizontal projector line, it is going to intersect with the vertical generator 771, so we will be obtaining the point G over here. So this way all the 12 points corresponding to the 2 cutting planes we have been able to locate over here. So let us join all of these 12 points onto the base so that we are able to obtain the development of the circular cylinder onto the base side corresponding to these 2 cutting planes over here. Now we can check. We have marked the central portion as blue color so that these points which are lying at the center, they are going to represent second cutting plane points of intersection, whereas these points A, B, C, D and J, K, L and A over here, so these points, they are corresponding to the points of intersection of the first cutting plane with the cylinder. So this way we have been able to obtain the development of the lateral surface of the truncated cylinder on the bottom side of this particular cylinder over here. So now we see that this top portion of the cylinder has not been intersected by the cutting plane, so we can join this portion over here. So now we have been able to obtain the development of cylinder, but this circular hole we have not been able to obtain till now. Now we are required to obtain the development of the circular hole, which will be observed as an ellipse onto this particular portion of the cylinder. That is, within this portion we will find that 2 ellipses we are going to obtain over here. One ellipse will be obtained corresponding to the hole which is obtained onto the front side of this hollow cylinder, and one ellipse will be available with us corresponding to the development of the rear side of the circumference of this particular cylinder over here. So now we have marked all of these points of intersection A1 dash, B1 dash over here in such a way that 12 points we have been able to obtain over here corresponding to the circular hole. Now we have to obtain all of these 12 points twice over here, once corresponding to the front face and once corresponding to the rear face over here. The point A1 dash, it is coinciding with the vertical generators 3-31- and 11-11-1. Similarly, this point G1 dash, it is again coinciding with 5-51- and 9-91. Similarly, these 2 points corresponding to the circular hole J1 dash and D1 dash, they are also coinciding with 4-41- and the vertical generator 10-101- over here. But these 4 points, that is L1 dash, K1 dash and B1 dash, C1 dash, so they are not coinciding with any one of the vertical generators over here. Similarly, these 4 points I1 dash, H1 dash, E1 dash, F1 dash, So they are also not coinciding with any one of the vertical generators over here. So what we have to do now, from these 8 points, that is L1 dash, B1 dash, K1 dash, C1 dash, I1 dash, E1 dash, H1 dash and F1 dash. Now 4 vertical projectors now you can check we have drawn over here, so that we should be able to identify the location of these points, that is C1 dash, L1 dash, K1 dash, C1 dash, I1 dash, E1 dash, H1 dash, F1 dash onto the circumference of the cylinder in the front side and onto the circumference of the cylinder on the rear side. So now we can check the location of these 2 points, that is B1 dash and L1 dash. So they have coincided with each other, as we are going to look at these 2 points from the top view projection. So now these 2 points L1 dash and B1 dash, they will be coinciding with each other and they will be available at this location between 10 and 11, and they will be available at this location between points 3 and 4 alongside the circumference over here. Similarly, the points K1 dash and C1 dash, again they will be coinciding with each other and they will be available onto the circumference at this point between 10 and 11, and they will be available at the circumference between the points 3 and 4 over here. So the first point we have marked as point A between 3 and 4. The second point corresponding to K1 dash and C1 dash, we have marked as point B between 3 and 4 over here. Similarly, these 2 points I1 dash and E1 dash, so again they have coincided with each other in the top view projections. So let us locate their location onto the circumference on the rear side and onto the front side. So these 2 points I1 dash and E1 dash, they will be available over here between points 9 and 10 on the circumference over here on the rear side, and onto the front side they will be available at the location number A over here between the points 4 and 5 over here. Similarly, the 2 points H1 dash and F1 dash, again they have coincided with each other in the top view projections and they have been marked at the point, this one, into the top view projections alongside the circumference between the points 9 and 10 over here, and on the front side it will be positioned at point number B over here. So this way the location of these 8 points, they have been marked onto these 4 points in the front view, 3A, 3B, similarly 4A and 4B, and over here also we can check, we have marked the points as 9A, 9B, similarly 10A and 10B. So this way, once we know the distances of these points A and B from point 3, now we have marked this distance 3A. So onto this vertical projector 3A, which points will be lying? The points L1 and B1 will be lying on 3A. Similarly, onto vertical projector 3B, which points will be available? K1 and C1 will be available onto this vertical projector line over here. This corresponds to 3B. Similarly, 4A. So 4A means which points we are talking about? I1 and E1 points. They will be lying onto 4A projection over here. Similarly, onto this vertical projection line 4B. So this distance we are going to evaluate 4B. So this distance from 4 we have marked as 4B. It is lying between 4 and 5 over here. So this 4B means which points will be lying onto 4B? Points H1 and F1 will be lying onto 4B. Similarly, onto rear side. So once these 4 points we draw onto rear side, we can check 9A, 9B. So we have marked the distances of 9A and 9B onto the circumference onto the rear side. Similarly, you can check 10A and 10B. So between 10 and 11, A and B points they have been introduced corresponding to these projector points over here. So this way onto 9A, which points will be lying? The points H1 and F1 will be lying. Onto 9B, which points will be lying? I1 and E1 will be lying onto 9B. Similarly, onto 10A, which points will be lying? K1 and C1 points, they will be lying onto 10A. This projector happens to be 10A over here. Similarly, onto 10B, which points will be lying over here? Onto 10B, because 10B corresponds to the points B1 and L1 over here. So this way we have identified onto these black color projection lines which are corresponding to the intermediate 8 points over here, these ones and these ones over here. So which points they are going to lie on which vertical projector line over here. So now let us evaluate the location of the 12 points corresponding to the circular hole onto the front side of the circumference and the 12 points corresponding to the circular hole onto the rear side of the circumference of this hollow circular cylinder over here. Now we observe that the point J1 dash, it happens to be the point of intersection of this circular cutting plane with the vertical generators 4 dash 41 dash and 10 dash 101 dash over here. So this point of intersection J1, it will be lying onto vertical projectors 4 4 1 and 10 10 1. So once we draw the horizontal projector line through this point J1 dash into this lateral surface development view, so wherever this horizontal projector line, it is going to intersect with the vertical generators 4 4 1 and 10 10 1. So the points J1 will be appropriately located onto the front side and onto the rear side of this developed truncated cylinder over here. Now the next 2 points which are available with us, they are K1 dash and I1 dash. So once we draw the horizontal projector through K1 dash and I1 dash, now we will be locating the points K1 and I1 on the front side, K1 and I1 on the rear side. Let us find out where these points we are going to locate. So we can check the point K1 is going to lie on the front side onto this vertical black color projector over here. So this will be corresponding to the point 3B. That is, on the front side, point K will be available on 3B. Whereas on the rear side, point K will be available onto the vertical generator 10A over here. So K will be lying on rear side on 10A. On the front side, it will be available on 3B. So we can check onto 3B intersecting with this horizontal generator, K1 has been located, and onto 10A, we can check onto 10A intersecting with this horizontal generator, point K1 has been located. Let us obtain I points over here. So I1 dash, it is the point of intersection of the cutting plane with, let us see which points onto the circumference. If I bring a vertical projector from point I, so onto 9B, point I will be located, and similarly onto 4A, I will be located. So I will be located on 4A and on 9B. So let us locate point I on 4A. We can check onto 4A vertical projector intersecting with this horizontal projector, we have obtained the point I1. Similarly, it is also available on the rear side with the generator 9B. So onto the generator 9B, so point I will be located over here. Now the next 2 points, they happen to be L1 dash and H1 dash. So once we draw a horizontal projector through L1 dash and H1 dash, so let us find out onto which vertical generators we are going to obtain the points L1 and H1. So let us first of all talk about point L1 over here. So L1 dash we can check over here. If we bring this projector down onto the rear side on 10B, L1 will be located. and onto the front side on 3A L1 will be located. So let us check. On the front side, the intersection of this horizontal projector with 3A gives us L1 over here. Similarly, the intersection of this horizontal projector line with vertical projector through 10B provides us with the location of the point L1 over here. Similarly, let us evaluate the location of point H1 dash into the top view projections over here. So once we bring projector through H1 dash, so we can check the vertical projector through H1 dash. It is going to intersect on the circumference at the point 9A onto the rear side, and onto the front side it will be intersecting with 4B. So let us check 4B and 9A. So onto 4B we can check. Onto 4B, intersection of this horizontal projector line with 4B vertical projector provides us with the location H1. Similarly, the projection of 9A over here with this horizontal line, it has provided us with the location of the point H1 over here. Now the next 2 points, they are A1 dash and G1 dash. So once we draw horizontal projector through A1 dash and G1 dash, now we observe that A1 dash, it is the point of intersection of the circular cutting plane with the vertical generators emerging through 3 dash, 3-1 dash, 11 dash and 11-1 dash. We can check onto vertical generator 3-3-1, point A1 has been located. Onto vertical generator 11-11-1, point A1 has been generated over here. Similarly, G1 dash, it is the point of intersection of the circular cutting plane with the vertical generators emerging from the points 5 and 9, that is 5 dash, 5-1 dash and 9 dash, 9-1 dash. So point G1 will be located onto vertical generators emerging through the points 5 and 9. So we can check onto 5-5-1, G1 has been located. Onto 9-9-1, G1 has been located over here. Now the next 2 points, they happen to be B1 dash and F1 dash. So through points B1 dash and F1 dash, we have drawn a horizontal projector line over here. So let us evaluate onto which vertical projectors I am going to obtain the points B1 dash and F1 dash over here. So let us check B1 dash first of all. So if we draw a vertical projector through B1 dash, so we'll check that on the rear side onto 10B projector, I am going to obtain point B1 over here. We can check 10B. It is this vertical projector. And on the front side, onto 3A projector, point B1 will be located. So onto 3A we can check. Onto 3A projector, point B has been located. And onto 10B, point B1 has been located. Similarly, point F1 dash, it is located over here. If we draw a vertical black projector over here, let us locate the orientation of this black projector on the rear side, 9A. This is projector 9A. And onto the front side, this projector is 4B. So onto 4B vertical projector, onto 9A vertical projector on the rear side, point F1 will be located. We can check onto 4B and onto 9A. We have obtained the point F1 over here, right? So next 2 points, they happen to be C1 dash and E1 dash. So now we have drawn a horizontal projector line through C1 dash and E1 dash points over here. So let us evaluate onto which vertical projector lines in the development area we are going to obtain the points C1 and E1 over here. So corresponding to point C1 dash, if we draw a vertical projector line, so point C1 will be available on the rear side on vertical generator 10A. Similarly, on the front side, point C1 will be obtained on 3B. So we can check on 3B. This is 3B. So we are able to obtain point C1 over here. Similarly, onto the back side, onto 10A, we have obtained the point C1 over here. Similarly, point E1 dash, it is lying over here. So from here, if we draw a vertical projector line, So on the rear side on 9B, we will be able to obtain E1 over here. And on to front side, on to 4A, we are going to obtain point E1 over here. So we can check on to vertical projector 4A, we have been able to obtain E1. Similarly, on to vertical projector 9B, we have been able to obtain the point E1 over here. And finally, the last point D1 dash. So D1 dash happens to lie onto vertical projectors emerging from the points 4 and 10. That is 4 dash, 4 1 dash, 10 dash and 10 1 dash. So now D1 point will be available over here if we draw a horizontal projector through the point D1 dash onto vertical projectors 4 and 4 1 and 10 and 10 1 over here. So this point D1 will be located over here. So this way, the 12 points corresponding to the elliptical construction on the front face, we have been able to obtain 12 points corresponding to the circular hole which is going to appear as an ellipse into the rear face of this particular circular cylinder over here. We have been able to obtain. So this way, we have been able to obtain the development of the lateral surface of the truncated cylinder which has been cut by an AIP cutting plane number 1 inclined at 30 degree to the horizontal plane, an AIP number 2 which is inclined at an angle of 45 degree with respect to the horizontal plane, and a circular cutting plane which is passing through the cylinder in such a way that the axis of the circular hole happens to be perpendicular to the vertical plane over here. And this circular hole passes through the center of the cylinder. So here, corresponding to the circular hole, two elliptical projections we have been able to obtain corresponding to the front face and corresponding to the rear face of this particular circular cylinder over here. So now we have been able to obtain the development of the lateral surface of this truncated cylinder. So this is all for today. So I hope that through this discussion you would have understood about the procedure to obtain the development of the truncated cylinder when the multiple cutting planes of different shapes and orientations, they are going to cut or intersect with the right circular cylinder. So we are going to continue with further discussion regarding few more illustrative cases of development of the surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.